Safety around power lines in the mining industry must be a daily commitment. In the mining industry, we're concerned about the well-being of those working near our power lines. In order to meet the demands of our customers, our mine has constructed a transmission and distribution grid. If the conductors of this grid were placed end to end, they would form a line many miles long. But people seldom notice these power lines. As long as wires stay where they belong, no one gives them a second thought. However, when wires are knocked down from a storm, or an auto or a truck strikes a pole, you must be able to identify these wires. That's why you're watching this video, to assist you in identifying these wires and lines found on utility poles in the mining industry. In our mining areas, other companies have pole-mounted lines, electric lines, communication cables, control fiber optic, and the telephone company lines may be present. In addition, you will find high-voltage power cable lying on the ground. Throughout the mine, you will have overhead and underground lines. However, it's the overhead lines on poles you'll most likely see. We will show you how electric power lines differ from other lines on utility poles. The differences need to be understood and the kinds of hazards they present when lines are down. Electric power delivers electricity at various voltages throughout our mines. Lines such as data communication, fiber optic, and communication cable pose minimal electrical hazards to employees since the voltages they use are extremely low. But to be certain, you must learn to identify energized power lines. All electric conductors should be treated as if they are energized, even though they may look harmless lying on the ground. If you see a line on the ground, consider it hot or energized and stay at least 100 feet away and have someone contact your supervisor while you warn everyone to stay clear. As a precaution, low-hanging cable and phone company lines could pose a hazard and should be guarded. If, for example, a downed electric power line crosses or becomes tangled with cable or phone lines, they could become energized. In this case, treat all lines as potentially hazardous. We apply a standard method of construction design for reasons of safety and efficiency. Looking at a typical pole, you can see the highest voltage electric lines at the top. These are the transmission lines. Below that on the cross arms are the high voltage distribution lines. And below them are the low voltage secondary lines. Next are the telephone, communication, and fiber optic at the lowest level. This configuration is standard. Safer lines are closest to the ground, with electric lines up high for clearances depending on the voltages. Energized electric lines carry various voltages and are grouped in several categories. High voltage transmission, high voltage distribution, low voltage secondary, low voltage service lines, and low voltage control cable. One other type, guy wires, do not carry electricity. Guy wires hold poles in place, sustaining them from abnormal loads caused by high winds. Since electrical lines carry voltages, you can judge how high the voltage is by the amount of insulators. Larger insulators or longer strings of insulators mean higher voltages. The highest voltage lines are transmission lines. These are sets of conductors which carry large blocks of electrical energy over long distances. Transmission lines begin at the generating station and extend to a transmission substation or switching point in the electrical system. The various transmission lines carry extremely high voltage. These bare conductors are insulated with long strings of insulators or large single insulators. The conductors and insulators are then supported by tall towers, steel, concrete, or wood poles. The small wires at the top of the structures are called static wires or ground wires. They are not insulated and connect directly to the metal hardware on the structure and attached to the ground. Their purpose is to shield the line conductors from lightning. Once transmission lines enter a substation, voltage is changed or transformed to a lower level. This is also where circuit breakers and other protective equipment are located. Substations act as distribution centers where the circuits originate. These distribution lines, also known as primaries, operate at various voltages. Distribution primaries are found on crossarms or on insulators bolted directly to the pole. These primaries may consist of 1, 2, or 3 conductors on a pole for each circuit. These lines, some made of copper, but mostly made of aluminum, are bare and always mounted on insulators. Conductors may be of the stranded or the solid variety. Some overhead lines have a weatherproof cover that provides no insulating value at primary voltages. Transformers and their associated fuse switches and lightning arresters tap or connect to primary voltage distribution lines, lowering their voltage as low as 120-240 volts for customer use. Installing transformers directly to the pole above the low voltage secondary conductors is our current standard today. However, in this example, a transformer is hung below the low voltage secondary. This technique was the standard years ago but is no longer used. However, some are still in service today. A third type of conductor is the low voltage secondary. Customer service wires are attached to these low voltage secondary lines. These conductors may either be open-faced bare wires on small insulators or wrapped insulated conductors around a single bare neutral cable. The insulated conductors will usually be gray or black. In addition, the service wires that carry electricity to the mine or your home may also be open-spaced or wrapped service cables. These service cables are also black or gray and attached to the customer's weatherhead. Wires that feed individual pole-mounted area or street lights are usually a single insulated wire wrapped around a bare neutral wire. However, some multiple lighting circuits are served by bare high voltage lines, commonly called arc circuits. If the lights are on, the circuit is hot. Although the emphasis has been on overhead lines, we do recognize that cars or trucks have driven off roadways hitting underground equipment such as pad-mounted transformers. These transformers sit on concrete or fiberglass pads located on the ground and are fed by underground high-voltage primary lines. Located next on the pole below the secondaries are communications, telephone, fiber optic, and control cables, generally black in color, are mounted on poles and secured to a steel messenger cable. In many areas, these lines are being installed underground. Cable TV lines will usually look similar to phone company lines. These lines are the lowest on the poles. In some locations, the phone company will use their own poles. These poles, usually shorter than electric poles, have main trunk cables mounted to them. Most telephone cables that are pole-mounted are full of phone line pairs or fiber optic cables. Like cable TV lines, these are held up by a single messenger cable. In a few locations, some older style phone lines still exist. Appearing as telegraph lines, they are fastened to pin insulators on crossarms. To sum up the differences between wires, look for their relative position on the pole. Highest voltages will always be on top. Look for glass or porcelain insulators and the location of weatherheads on buildings. This will assist you in identifying power lines. Also, look for cable TV and telephone lines with messenger cables and large trunk lines. Learn to identify telephone company and cable television service drops. These lines attach to various locations on a building and are smaller than electric service drops. Being able to identify various types of wires will assist you in several ways. First, to maintain safe clearances while working around various lines. Second, being able to assess the relative hazards you may face around downed power lines. And third, getting the appropriate agency out to repair any damage or restore service as soon as possible. You should place top priority on wires down. If you see wires that have been torn down, stay clear and have someone call your supervisor. We hope this video will help you better identify the various pole-mounted lines in your mine's transmission and distribution system and provide a safer working environment for all miners. And remember, call your local utilities at least 48 hours prior to any excavation or work near power lines.